pleasure to welcome you all to Engineering the Future by Witmas. Today, we are very excited to have with us Mr. Vishwas Vaidya, sir, an engineering consultant, innovation mentor, and industry faculty who brings with him valuable experience at the intersection of engineering, innovation, and industry. And as engineers, we often focus on solving technical problems, but turning these into solutions require meaningful innovations and much more. So today's session is an opportunity to develop the mindset needed to build for the future. Sir, we are very happy to have you
Okay.
with us today. A very warm welcome to you. And
Yeah.
now, without further ado, I hand it over to you.
Thank you very much. So, as I was told, it is a mixed audience, mixed engineering audience. That is why I have chosen a topic that will be of interest to everybody. So, particularly when it comes to engineering research, and that is what our career as you enter industry as a self-employed person or get employed somewhere. Engineering research is something you cannot wish away. You may be in sourcing, marketing, still as an engineer. Engineer research is definitely uh, is relevant. Can somebody tell me? I want this to be interactive as possible because one thing it is online and I don't get the feedback much because I cannot see your faces. Can somebody tell me what is research? What do you understand by research? Because this is where the gap in understanding starts. Not everybody knows what is research.
Uh, I
Yes.
feel that research is a step-by-step process of collecting or studying information into fields and all, or to solve new problems.
Come again. Come again. Hello. Generally, what is it that constitutes research? Research must have a goal. Hmm? Any research must have a firm goal. And to reach that goal, we need to have minimum two paths which are non-trivial. Two paths which are non-trivial. By non-trivial, I mean they should not be mm, obviously wrong or obviously not feasible. Hmm? Minimum two paths to reach. It can be multiple. And which one is better than others? That is how the definition of research as far as the research methodology subject is concerned. For example, uh, last week only I had gone to some academic institute and I was asking what kind of research they are trying to explore. So one of the person in the audience or in the meeting, they told me they want to do vehicle to vehicle communication using 6G. Vehicle to vehicle communication using 6G. All of you would have heard that V2V is going to come in India from 2028, correct? No? 2028. I'm not sure not everybody has heard of it, but there has been a declaration. Now, see the fallacy here. 6G has not yet come. And even in the country like India or wherever, hmm, you may not have even a range sometimes. That is one. And vehicle to vehicle communication, like you have two vehicles. One is, both of them are not visible to each other because uh, they are round the corner. You are not able to see. No, in India, what we do, we play the horn. We play the horn. And actually, that is our B2B communication. Why others are not able to drive in India? Because they don't know the language of horns the way we do. So 6G is an overkill. First thing, it is not feasible. It is an overkill because even 5G requires such a larger infrastructure. And if you are only targeting vehicle to vehicle communication, you have to see the what is the real time target constraint you are being you are targeting, because vehicle motion itself is very slow compared to 6G. 5G is for say robotic surgery, where 1 millisecond of latency people are targeting. That surgeon is in USA, patient is here, and with through robo there is targeting surgery, split millisecond decisions. So that is not the case. So B2B using 6G is only a pseudo glamorous title. It is not research. So anyway, that is just wanted to have everybody on the same platform. So how I start is, actually all of us should be, I will also encourage study history of research, history of engineering inventions, innovations, and we'll see what lessons our earlier generations have learned, where the research has gone, engineering research has gone, what mistakes they have made, what are achievements they have attained, and accordingly we should see can we learn from that and go ahead. And what it involves, how not to conduct research is also important. I just now gave an example how not to conduct research, case studies, lessons. I'm not sure when I came last time, there was a limited audience, a mechanical ASME, because I generally start from bouncers. You can see left side is a photograph in New York City, published in perhaps New York Times, and the year may be 1850, 1860, something like that. You can see there are so many horses around. And right side is any modern city, crowded with vehicles. So, which is a cleaner mode of city transport, horse-driven cars or automobiles? Can somebody answer? Tanisi, can you answer this? Or can you motivate somebody else, those who are sitting? All of you are together or you are at different places? At rooms or homes?
So we are all at rooms.
You are all?
They're in rooms.
Rooms, acha. But you are all together, correct? Or no, your own hostel rooms, correct? Huh?
Yes, yes.
Some of them may be together. So can you attempt to answer this question? Anybody? Can you answer anybody? Which one is clean? Horse or automobile?
So obviously, like horse would be cleaner because it's natural.
Natural is horse. Okay. And
But not much efficient.
what is not efficient?
Horse
Horse.
driven carts.
Okay, okay, okay. Tanishi, you are speaking correct, na? Any other opinion? Any other student? Can you attempt this? She says horse is clean, but it is not efficient. But I just want to ask Tanishi, if you are driving a bicycle using your muscle power, and you compare that with a IC engine or EV car, which one is the more efficient mode of transport?
So that's what I said. Like automobile car, it would be more efficient, but then cleaner would be bicycle. Yeah,
See,
horse driven car.
1 minute. Do you know efficiency of gasoline engine, diesel engine?
Uh, Output by input, it's around 50%.
Around?
56%.
Oh, can somebody 33 is 33 is a very difficult limit. Gasoline and diesel engine only. 33% is a very, very difficult limit. And actually, muscle power is the most efficient, because you are not consuming any fuel as such apart from what you eat. Suppose you go for even 10-kilometer bicycle ride, there is not much of a change in your diet, not much of a change, efficiency point of view. Actually, muscle power is supremely efficient. Okay. And you say, what is cleaner? Horse is cleaner, you said, huh? Anybody, any other answer? See, if this is a case, are we doing research in correct direction? She said efficiency, but efficiency, actually it is proven. It can be calculated also. Muscle power, there is no loss. There is no this thermodynamic cycle, where a lot of energy goes away by heat. Actually, your muscle-driven bicycle, if you calculate calories, you try that as an engineering exercise. That your own weight you are taking ahead. Because there is no dead weight, no curb weight like your ICG, like your vehicles. And that is why it is supremely efficient. All you do is muscle, and muscle efficiency, the moment you exert your muscle power, it goes. There is no loss, not much of a loss. But actual answer is other way around. When if you see the left side photograph, the actual news item was that in 1 square kilometer, there were kind of 1,000 horses in 1 square kilometer. What is the fuel they are consuming? The fuel which they are consuming is grass and whatever they eat. But now you think of their exhaust. 1,000 square kilometer, the amount of stink all of them you're jointly generating was so atrocious, so unhealthy, that everybody heaved a sigh of relief when automobile came. So automobile, as such, if you see the cost benefit ratio from all the angles, the automobile really relieved. It came as a clean vehicle. We think that is a pollution which is doing, but if you see the horse pollution, uh, horse being actively used as a mode of transport, not the horse in some holiday resort where one or two horses are only going, that is different. But you imagine everybody is traveling by horses like they are shown in the left. So that is how it is. And one has to study from history. Why did we make a mistake in coming from horse-drawn to automotive? Because if it was a mistake, say today everybody is talking about clean mobility. Have you heard anybody? Let us all go back to horses, because that doesn't require any engineering research at all. Whatever research required for horse-drawn car, they already been done. So that is what it is. This is a very, very interesting question. Can computers have a gender? Have you heard of such a question earlier? Forget answering this question, but have you heard of such a question? From our AACB, I have forgotten name. I know Anushka maybe final year, but I'm not sure she is there. But anybody else, see, I tell people, those who want to succeed in life, the first thing should be initiative. Hmm? Even though you are wrong, doesn't matter. Hmm? Unless you take initiative, answer, discuss, different. Has anybody heard a computer with a gender?
No, sir.
No, no, correct. No, they have not heard. So now let me tell you the history. Second, see, computers is only a device, whereas problems existed which computer should solve. Even during all the wars and even for centuries, decades, the problems were there. One of the major problem during war was producing a gun chart. Producing a gun chart. What is a gun chart? A gunner. Suppose in USA, some or we in India, we want to have a gun pointed towards enemy. So what should be the angle of gun so that it reaches the target, the salvo, the gunfire should attack the right target, right destination. That is a mathematical problem, worthy of being solved by a computer actually. This problem has been there even in the absence of computer. This problem has been there. What is this problem? What is the angle? Angle means angle is a solution, but it is a solution of a multivariable non-linear differential equation. The equation was known, theory was known, mathematics was known. What are the variables? Variables are wind speed, humidity, temperature, time of the day, many other things. And of course, your source and destination. So with that, there used to be a gun chart. Every hour of the gun, what should be your angle? Because Earth also rotates, everything happens. So this gun chart were outcome of a mathematical exercise. So since all the men folks were going to battlefield, women which were mathematically qualified, math savvy women, educated, mathematically educated women, they were given this task of solving this equation, non-linear differential equation numerically. You must have done numerical solution of differential equations, correct, no? And also, actually, a differential equation can be converted into what we call as a difference equation. That every time you discretize it and every time instant, what is the value solution you will take? That can be calculated algebraically. So, you can see a room full of women here, and every desk has been assigned one term. So, at the end of 24 hours, the entire gun chart will get produced. And even though some rudimentary analog computer was there to help them for some basic calculations. So the military would employ, these are all military employees, and name of the position they were occupying, their designation was computer. So these are human computers which are forerunners of the computers which we see today. And same thing goes for weather forecast. They had woman computers because they were trained into this war and they could do it. Even if you see this Oppenheimer movie, Oppenheimer book, if you read, they mention this. There is a ladies were employed as computers, and that is how the need for automatic computer or computer machine was felt that something which will do it automatically. That is how they started relay logic, then walls, then transistors. That is how there is a progress. So computers had a gender. Necessarily they used to be ladies, and that is a forerunner. What is the lesson here? Again, looking at the history. you can see which direction the research has taken place. It started with a problem. Problem was there. Problem is here today also. Now the computer on the fly will give you gun chart, even simulation, everything. How many of you have heard about Richard Feynman? Richard Feynman. He was a Nobel laureate. He has written famous books. Any idea? You should read Feynman's lectures on physics. Feynman's lectures on physics, volume 1, volume 2, volume 3. There is an interesting story. I will come to this slide, but even before I tell you about this slide, I want to tell you the background behind Feynman's lectures of physics, volume 1, volume 2. You should read all those. At least you have to browse them. It will be there in your VIT library, I am very sure. See, when Second World War was over, Second World War was over almost. Both Russian forces and American forces, they wanted to divide the wealth which Berlin had. What was the wealth they had? They had brains behind V2 rocket. Because Hitler wanted to launch rockets, long-range missiles, rockets. But by the time the technology got matured, Hitler was already defeated. But both Russians and Americans, they had decided that they will amicably divide it. But what happened? Americans outwitted Russians, and they hijacked the cream of German scientists, engineers responsible behind their rocket program, missile program, and hijacked them and went away. When the Russians entered, they were really angry. Like only draftsmen, technicians, this lower type of manpower was remaining. But anyway, Russians had taken them with them. And Russians, both the forces, they had also taken with them the burnt out pieces of the rockets and everything. And then the Russians, they could get hold of one reference book these Germans had used, and that was written by a Russian. If you see the history of rocketry, I am not able to pronounce that person's name, some Tchaikovsky or something. So actually Russians, the father of rocketry was from Russia. But anyway, so with this, Americans were complacent that they will win the Cold War. Why? They had taken the cream with them, German cream. And which was the first satellite launched in the world? Can anybody tell me? 1957, 58. The first satellite in the world was launched. Does anybody know about it? Sputnik. Have you must. That's why I want actually now offline, because looking at faces I am able to make out. Sputnik is the satellite, Russian. Some of you would have heard of it, correct? No. The Sputnik was launched by Russia, first satellite in the world. So they were the first who were able to, in a way, conquer the space through their satellite. And this Sputnik was making a round, going around the globe around every hour, few minutes here and there. Sputnik was going all around. And Russian, American computers were receiving beep from Sputnik. Sputnik was kind of teasing them, see, we have won the first milestone of our Cold War. And then their President Johnson was worried, and he called for a meeting of all the scientists in America, including the Germans for whom they had hijacked. And one of the American scientists, he assured Johnson. hmm, What did he assure? He assured, "Sir, don't worry. Hmm, Yes, we agree that Russians have taken a lead, but ultimately we are going to win this space race," which became true. His words became true later on in a decade or so. So, what is the reason? Naturally, the president wanted to know how can he be so sure. He said, because our Germans are better than their Germans. See, our Germans are better. There's a famous quote. Our Germans are better than their Germans. And actually, when I deliver lectures on automotive electronics, I discuss this event and I say, now it is other way around. Uh, which brand of automobile vehicle will win? Only when our electronics is better than their electronics, then only that brand wins. But how Penman comes here? So this America, all the academic community, professor, education industry, all of them started doing introspection. What is it that we are lacking? Why we are? How Russian can? Russian scientists have overtaken us, and Penman was also involved. And Penman found that physics education has to be strengthened in universities. And that is how he delivered lectures on physics in universities. They were, I think, they might have recorded those lectures using these movie machines or whatever. And he published also, like Penman lectures on physics. 1, 2, 3, volume 1, 2, 3. So this is the stature which he occupies. He was a Nobel laureate, and also his lectures are so famous that still they are very famous in the world. So he has written a very famous biography, autobiography, that also will be there in your library. Surely you must be joking, Mr. Feynman. That is the title of his autobiography. So what is the story here? He was 14-year-old school child, not at all into university. University education still away. Forget engineering also. And that is the time when First World War was going on. In the First World War, people had started listening to radios, wall radios. You can see there is a radio which is full of walls, which is having heaters. The heaters, what is the principle of this wall? There it has a cathode, anode, and a control grid. You hit the cathode, there is a heater. So, moment you hit the cathode, the electrons will escape. The cathode will be attracted to anode, and in between there is a control electrode which will control the flow. Like we have transistor now, semiconductor, but similar principle. But this is thermionic emission, and through that the wall radios had become very popular, and daily people wanted to eagerly listen to the news, which had never happened before in any war. Anything happens, maybe in a week or so, you will get. If it comes on teleprinter, then you are lucky. It will be next day or whatever. But this was almost real time. And the problem was nobody was able to repair. Very few people were able to repair these radios. This is like our electric vehicles today. Many times I hear the electric vehicle has gone bad, but not properly repaired. They say it is repaired, but the problem occurs again. So he was a smart child, very intelligent, future Nobel laureate, and he had developed expertise on his own, like a hobbyist, to repair radios. He had become very famous. That here is a child, you give any radio to him which is not working, he will somehow repair. So from one end of America, somebody came with his car to meet Penman during this war, saying that his radio is not working. And he bundled Penman inside his car, saying that, come, you have to go along with me. Penman was angry. Hmm? Saying that just because you are a grown up and elder, you can lift me. Hmm? It is not proper that without my consent, you are taking me ahead, hijacking me. It doesn't matter. Now you tell me what is wrong with your radio. So the person who was driving, he said his radio generally works fine, but when he switches on the radio, for 5 seconds, very loud noise is coming through it. Then everything goes ahead. The penman was even more angry. If this is a problem, solution is very simple. You can plug your ears through your finger. Put your finger in your ears. Problem solved. That's what he was even more angry. Such a silly problem is taking me, but doesn't matter. When they reached the destination and when penman really heard the loud noise coming out of radio, penman was convinced this has to be repaired because noise was so loud and hurting that once you hear that you don't feel like again switching on the radio. That is a problem. Okay. Now see, the problem is so tricky. Engineering, that is where research mind, how it will require a research mind definitely. Why? And now what is the goal here to repair the radio? There are many ways. What other people may do, they start by trial and error, replacing each and everything till it works. Then you don't know what exactly has gone bad, or it has really been rectified. Now, what is the trick here? If you say element X was not working, and how can it work after 5 seconds? That is a question. There are possible culprits. Say you want to solve an engineering problem. Oh, I tell my people, my other students and team members, you have to divide the system, or even divide the problem in small parts and attack each part at a time. But here, what is happening is the problem is occurring only 5 seconds. And how can it get rectified on its own? But many critical problems are like that. They occur once in a while. Here, at least it is occurring consistently after every switch on. So, Feynman said he is going to solve the problem. And he went into deep thinking process. So, he was going pacing to and fro, going up, going down, going up, going down, pacing to and fro, thinking in that room where the radio was kept. The owner is getting restless. 5 minutes have happened, 10 minutes, 15 minutes. And there is no sign that Feynman will go near to the radio, start probing. No sign. So finally, after end of half an hour, the owner asked, when are you going to start repairing? So Feynman answered, don't disturb me, I am repairing the radio. Don't worry. Repairing is going on. It was going on inside his head because he was obviously not an engineering student, not even a university science student. And he is all the while thinking what can be the culprit and which culprit is such that after 5 seconds it becomes okay. At the end of 45 minutes, he solved the problem in his head. He approached the radio and he swapped two walls. You can see a couple of walls here. Similarly, what he did, he swapped the positions of two walls and he switched on the radio and radio started working. The radio started working. How? Because many of you are from mechanical, electrical. So in his head, he was evaluating many possibilities. The only possibility which he found look plausible is difference in thermal time constants of the adjacent walls. One wall is getting hot very soon, very fast. Other wall is getting hot very slowly. The one which is getting hot slowly, it should have been doing the work of processing the signal. See, the signal will come as a radio wave, riding on the radio wave modulation, and Radio is a multi-stage circuit. There are multiple amplifiers and then demodulators and again amplifiers. That is how it reaches the speaker. But if early stage amplifier is cold, it will not do its job, and your signal will go unprocessed. Go unprocessed. In unprocessed, it is a junk, and junk will enter the hot. The junk will enter the wall, which has become warm. And that is where that warm wall ends up amplifying the junk, and that is how through speaker you are getting loud noise, because all the information got killed because of the non-working wall earlier. How it started working then after 5 seconds? Because it became hot. So that is how he clearly found out, and he was able to do it. So what is the lesson here? Lesson here again, this is a goal, but you should spend enough time in what is the problem you are solving, rather than how you will solve it. How you will solve it, and that is a mistake many researchers, many engineers, and in other field also, many of those who want to solve a problem do. They don't spend enough time in understanding a problem, and they are in a tearing hurry to start solving. Forget the homework, because when their bosses are looking at it, their other stakeholders are looking at them, they become happy that he is doing something. See how soon he has started working. But those like Feynman, those who really want to be successful, they say, unless I understand the problem, I am not going to start solving. So what is working on what is a problem is so important, and unless you are very clear what is a problem, you can do experiment to know but this is the problem, you are understanding correct. You should not start solving the problem. Otherwise you will end up solving wrong problem rightly, and that is what happens. That is where that 6G, professor, he said he will use 6G to have V2V communication. He is doing a wrong problem rightly. Anybody from computer engineering here? Who is the father of software engineering? By software engineering, I mean software safety engineering. Who is father of software safety engineering? Can somebody attempt? Again, the answer is it had a mother. Of the software engineering has a mother, not a father. That is the Margaret Hamilton, which can see in the left side. We already discussed that computer used to have genders, and when computers really arrived, wall computers, they were using the same walls. The same walls were there for having AND gate, OR gate, logic, executing instructions. The same women who were now experienced in solving maths problem in a structured manner, they were employed or they were put into software domain to develop the program. And the Apollo 11, Apollo, you can see the three jubilant gentlemen, and that is where they were a few years ago, few years or few months ago, all these three were felicitated, out of which one was no more. And now even a couple of people have gone. But nobody, not even Society of Women Engineers, they talked about Margaret Hamilton, who is the real heroine behind this victory. How I will tell you, behind this victory. What is it? She was made head of software engineering. The word software engineering, I mean the discipline in a way was started through her efforts. The actual term might have come later. And even computer engineering textbooks, they do not have her name. So, or many times I deliver lectures, and most of the professor, women professor in computer engineering, they have not heard her name. But anyway, let me tell the story. What she had done. Actually, why computer was required? Let us first see why computer was required in Apollo 11 or Apollo program. Why did it require a computer? Again, there is a very wonderful book which is available in PDF form. Digital Apollo. Digital Apollo. All the engineering problems those people faced are discussed. One of the problem was navigation. Navigation. How do you know you will really reach moon and not deviate from your path? How will you know that? That was a question mark. You may say that there are sensors and all, but all sensors have errors, statistical errors. Whatever you do, you cannot get a sensor with perfectly zero error. And if you are going such a long distance, these errors will go on accumulating. And instead of moon, you may reach somewhere else. That is the fear everybody had. How am I sure? Even though it is a manned flight, actually it was going to travel like a pilotless vehicle. Only the last leg of few hundred meter, these pilots are going to take charge and take control of the spaceship to hit the surface. That was a plan. So if everything is so automatic, how are you sure you are not deviating from your trajectory? So that time there was a mathematician called Kalman. He said he has already developed a mathematics for such problem. It is known as Kalman filter, and this mathematics now is so famous. It is used in so many situations. In electric vehicle, it is used for measuring state of charge of the battery, also the battery life. It's Kalman filter. So he described that mathematics. It's complex, generally covered in master degree. I'm not sure anybody undergrad is studied Kalman filter here, but you might have heard of it. So the Kalman filter has to do with matrix calculus, and there are matrix equation. Um, and it goes on. What is the philosophy behind this mathematics? You predict the next reading. You predict the next reading, next outcome. And when the actual outcome comes, you find what is the error between the prediction and actual. Based on that error, next time your next estimate should be statistically corrected. That is how it is. That is how that is a basic philosophy, and there is an equation. They call it Riccati equation. Again, the Riccati was a 17th century Italian mathematician. His theory Kalman used, and he made this equation. And now, what is the next problem? The next problem is who will solve this Kalman filter equation in real time when the space is airborne? The answer was computer. But the computers that time, even though that time actually semiconductor computers started coming, transistor was invented in 1948, and this is past 1960. By the way, in 1961, the Kennedy had declared that within a decade we are going to reach the moon. And 1969, that we are just 2 years away from that prediction. And then people said, yes, computer can do it, but that time the computers were occupying an entire floor, the entire room in a factory. There used to be a computer room. So how that room can come in this spaceship? Spaceship only has nose cone. In a small space of those cone, this electronics should be accommodated. And that is where the electronics had to be miniaturized. And that's why you had integrated circuits. First integrated circuits and logic gates, they were all built. And the department of software development headed by Margaret Hamilton. They were supposed to program this equation plus control and monitoring. We call it SCADA. Control and monitoring function also done by her. You can see the printout is of the same height as her. And what did she do? She had taken all the adverse possibilities into account potentially. People would laugh at her saying that why are you being devil's advocate? But she was proved right. If this happens, how the computer should save the situation, how to salvage the situation out of every deadlock. That is the kind of software she has written, and that is so useful today in our modern autonomous vehicles, modern electric vehicles. This software engineering strategy, they call it functional safety. But anyway, so the computer had a limitation that at a time you can press only 7 commands maximum. You can press only 7 commands to see the parameters, to give some command. At a time only 7. Eighth command, moment you press 8th command, the computer was going to hang. It was a primitive computer with very less memory, very less resources. It was going to hang. So what happened? The Aldrin, Buzz Aldrin, he was so excited because they were able to see the moon surface. They were very close to moon surface, and now they had taken charge of the vehicle, and they were about to reach in next 3 minutes on the moon. So he went on entering command after command to see what is the status of various parameters, what are the various figures. He forgot that he should not be entering 8th one, and he entered 8th one. Entire computer screen went black. Entire computer screen went black. Now they have 2 choices. Choice number 1, come back to Earth. And this they had simulated. All this they were trained that if this happened, how to come back. That everything was told to them. And simulation also they had said that if something happens at the last minute, how will you come back? Choice number 2 is take the risk and go ahead. But that is where the software of Hamilton, Margaret, came to their rescue. She had imagined this condition. And what she did, she killed all the tasks which were not necessary for journey of the spaceship. For example, he is looking something on the screen. How does it matter? We only have to go ahead. He did not know. Similarly, all the tasks were killed, and the spaceship beautifully went ahead in 3 seconds, 3 minutes, and touched surface of the earth. So that is the credit she is having. It is there in Wikipedia. It is there widely reported in literature, but not included in any of the textbooks. Similarly, so many things are not there in textbook, including the Feynman story. So these are the questions you did not answer. But you can see what you can learn. You can learn even from a horse. See, is horse a autonomous vehicle? Yes, in a way. You can train them. Math competence. There are many people who hate mathematics. But actually mathematics will strengthen your logical thinking and also tell you, also allow you between 2-3 possible technologies which is better. Actually, this Monday only I am delivering a session in a local college, engineering applications of mathematical transformers. See, the penman is, what is the lesson? You have to do right thing rightly. And even if you do right thing wrongly, you know it is wrong because you have done right thing wrongly. And you have to spend a lot of time in understanding the research problem. Software engineering research is the safety. There is a modern days they call it design failure mode effect analysis. Why it is needed? Why it is needed? I think another 10, 15 or half an hour will. Can somebody tell me uh, the turn of last century, 1905, 1906, even 1910, also 1896. Which vehicles were more popular, or which vehicles had more market share, electric or IC engine? Electric or IC engine? Hmm? Let me come out. People are how many are there? There. Which one can somebody answer? Do you know? Or hazard a guess? Just guess it. Hmm? Guess it. Which one was more popular? Which were more popular? Electric or IC engine? Okay. But that is a guess, I think. But actual answer is electric vehicles were more popular. Why, I will tell you.
Sir, actually, I think electric, there was a low grade invention of electric vehicle and it got popular, but after that it died due to some kind of funding gap, I think.
Who? This is Tanishi again or somebody else?
Yes, sir.
Yeah,
Tanisi.
very good, very good. I am going to reward you for the answers, but answers are wrong, doesn't matter. But at least you are answering. Yeah? It is not the funding. IC engine was killing the riders, killing the IC engine was killing the vehicle occupants. That is the reason electric were popular due to many reasons. The funding had nothing to do. I will tell you. Uh, when an engineer is asked to solve a problem, as I said, right thing rightly, correct? You want to go devise a system, that transportation system that will take you from point A to point B. Electric motors were invented way 1850 or something like that. They were there. DC motor was there. Battery was also there. And you want to have a vehicle which should have an engineering solution which will take you from point A to point B. What is the first thing you will do? You will expect. First thing you will expect is the vehicle must start with minimum trouble to the driver, minimum intervention, minimum uh, nuisance to the driver. You are starting a fan in your room. Are you supposed to crank? No, it is just a switch. So that is where electric motor came to their everybody's mind. Hmm. Number two, what should be the starting torque of a transportation solution? Of a transport system, should the starting torque high, low, medium, or it can be anything? It has to be high. Why should it be high? That way only you are able to attain the maximum speed as soon as possible. If you have traffic, you are able to merge with traffic as soon as possible. What happens to IC engine? Lowest possible torque. Actually, there is no such thing as zero speed in IC engine. Correct? IC engine starts 1000 RPM, and uh, new learner ends up stalling the engine many times. Very, very new learner. Because engine hardly generating any torque at the low speed, whereas the transportation solution demanding infinite torque. Again, the motor was winning, EV motor, because EV motor has infinite torque due to Ohm's law. Battery divided by the near zero ohm armature resistance, infinite current. So even now, if you go to a dealer and say, I want a ride of a electric vehicle, whether two or four wheeler, you are immediately struck by the near infinite pickup it has generated. This was number two. And number three, drivability. Drivability is the how fast and how accurately a vehicle system obeys the wish in driver's mind. Again, electric vehicle is very, very agile. Actually speaking, electric vehicle does not need friction brake. It is a 1 foot vehicle. You press the accelerator, it goes ahead. You take it out, it stops. Many times I ask if there is a road with bumpers every few meters. Bumpers means your speed breakers. You watch an electric vehicle passing. Electric vehicle is able to stop, dead stop at the start of that bumper and then slowly glide over. Whereas IC engine cannot do that unless you stall it. So that is the reason in every single way electric vehicle was superior as a transportation solution. And when it comes to range, they did not need that much range. 12 meter is fine with them. 11 kilometer, 12 kilometer was fine. That is how the electric vehicles were winning. And what was happening with IC engine vehicle? IC engine vehicle did not have a battery at all. Very few people know. Can you imagine a vehicle without battery? Now, so how will they have lamps? They had acetylene cylinders. How will you have starting? Starting, there is no motor. You have to start with muscle power. You have to start with muscle power. There is the crank rod is there. Go and pull that crank rod. Moment you pull the crank rod, engine can overpower your muscle. Engine will overpower your muscle, and if you happen to let go of that rod, because rod will overpower you, it may escape your grip and it would touch your body. It will hit your person. It will hit your face, chest, or whatever, and you may be fatally injured. And that is how now you see the range IC engine was giving that time. Point A to point Z, heaven. You are on the earth, you directly get transported into heaven even before you start. And electric vehicle was going point A to point B only. Now you can see what infinite range they were offering. And what happened once the IC engine, to start IC engine, no ordinary person can start. The lot of muscle power required to pull your crank rod. So what people used to do, you pull the crank rod and you accurately sense when it starts. That is the instant you should retard the ignition angle through a lever. Moment you retard the ignition angle, engine can reach the cylinder piston can reach the top dead center. But since you have retarded the ignition angle, there is no spark ignition there. And it goes up and comes down without a spark. And halfway through, a delayed ignition would come, and that is how your engine is tamed, weakened. The moment engine is weakened, you can comfortably release your grip. That is the way to survive. But not everybody every time was able to do that. The story goes, one lady was driving Chevrolet IC engine vehicle on a flyover and her vehicle got stalled. She was looking for help because she was not sure alone she can do it. And one Chevrolet engineer was passing by. He said, it is the car made by my company. It is a matter of pride for me to help my own customer. So he went there. He pulled the crank rod. Moment he pulled the crank rod, the vehicle, its engine did start. But he was not able to accurately synchronize the ignition lever. Retarding of ignition angle could not be synchronized by him. That is how that rod escaped his grip. It hit his jaw. He was hospitalized, and there was a casualty. Now his boss back home, back in the factory, got very angry. Chief engineer of Chevrolet motor vehicle program. He said, today one of our engineer has gone to heaven. How many people are you going to kill like this? You are talking of research dying. Forget research dying. People were dying because of IC engine. So actually, there had been a discussion that we must have electric start. of these engines. This fact was being discussed and thought to be the solution last 4 or 5 years. The electrical engineering team of your that Chevrolet, because they may have one electric vehicle also, was working on it. They were asked to work. So the chief engineer, being angry, he said, call all the electrical engineers. We'll ask them, what are they doing on this assignment? What is the status of your work? So those people, when they enter his cabin, they came with the calculation. He says, see, here are our calculation. What is the calculation? They say, suppose this is a 20 HP engine. We want to start. Our calculation say to start 20 HP engine, we need 20 horsepower of motor. So 20 horsepower of motor is quite large comparable to engine size. And in the same single engine compartment, how can I make both motor and engine coexistent? That is the problem we are facing, and that is how we are not coming up with any solution. And only solution we can think of is remove the engine, put our motor and battery. Then you get electric vehicle anyway, which is a known solution. Why should you have IC engine with electric start? That is the calculation we are saying. There is a very important electrical engineering lesson here. As we go ahead, it will be revealed. But again, this story is not there in any of the electrical machinery book. So, chief engineer was still angry because he has lost a person. He said, I am not going to listen to anything. No excuse. I want electric start. By hook and crook, you have to do it. Don't say it is impossible. Then the electric engineers, they said that let us got somebody who is innovative and whose innovations have gone viral, who is very famous. Name of such an engineer was catering, which is there in photograph. Even today we have Catering Institute of Technology in USA. He had delivered many groundbreaking innovations to USA and world. Automotive, non-automotive. So actually, I think he was the person behind first automatic transmission, first automatic working transmission. So that time he had become famous in the country because of a solution which he had given. What is the solution he had given? His solution was motorized cash register in retail stores. Motorized cash register in retail stores. What is it? See, thieves are everywhere. Whether you say USA, India, everywhere thieves are there. A cashier who is standing in or even sitting with a revolving chair in the retail store, he accepts the cash, puts it in his cash drawer or cash register, closes the drawer, and he turns his back because he has to attend somebody else standing in another direction. Moment his back is turned, the thief will open the cash register, pilfer the cash, steal the cash, and go away. So by the time he again comes back and looks in the drawer, it is empty. What is the solution? So catering said, I am giving you a solution. What is it? He brought a small motor with a clutch and a small circuit with a battery and a switch. So he says that the register, this cash register, the door will be operated by a motor, motorized motion. So it will open and close the door of the cash register. Even today, our vehicles, they have motorized locks. And there is a clutch to disengage when you are not required. Otherwise, motor will also stall. So, with that, the problem was solved because the cashier can operate a simple push button which is accessible only to him, kept very close. And he puts the cash, presses the button, the motor will shut the door. Now thief cannot open it, because if thief opens because of the sound, it is not easy. He will be caught. And whenever you want to again open it, press the button again. The motor will open the door, put the cash. That is how the motorized cash register was invented by him, given a solution which has solved the burning problem. So all the electrical engineers said, please call Mr. Catering, the hero. And we are very sure he will also look at our calculation and endorse that what we are doing is correct. He will say, yes, he agrees with us. That is what we are very, very sure. And once he says, you have to agree, we are as smart as him. That is how electrical engineering team was doing. See? And when catering was called, problem was described to him. You read all this history. Problem was described to him. He said solution is in his pocket. Everybody is surprised. How a engine solution, which is the size of engine, can accommodate in his pocket, because he had heard of this problem, and he had brought the same small motor and clutch in his pocket for this discussion. And he said, I will mount this motor, engineer it such a way that it will start the engine. Okay, everybody is crossing the finger, and he mounted the motor, did the wiring, and he started, pressed the button. Engine started beautifully. Moment engine started, the motor was declutched. The clutch disengaged the motor. That is what happens even today. And that time, the electrical engineers realized the blunder they were making. What is the blunder? Blunder is electric engineers had forgotten how a wire works. That is so much important. How a wire works, because motor is nothing but a mass of wires, winding. You have to know how a wire works. How a wire works, I will tell you. If you have a wire with insulation, enamel or whatever, 10 ampere rated wire, you connect it from one end of the room to other end of the room, wall to wall, opposing walls. And it is rating is 10 amperes, but you pass 100 amperes through it. What will happen to the wire? Actually, nothing happens to the wire, because copper cannot melt. What gets damaged is copper may become hot, and because of the temperature, insulation gets damaged. But this is single wire, even insulation get damaged. From what are you insulating? You are not insulating from anything. But if you have motor winding, and for a 10 ampere motor, you are passing 100 amperes for multiple seconds, more than a minute, more than a few seconds, then insulation of a turn will get damaged, or two adjacent turn will get damaged, motor will burn. But if you are able to switch off that motor within 3 seconds, all the mechanical people would be studying heat transfer. So this has a thermal time constant, is a thermal mass. So the trick is a 1 kilowatt motor can easily deliver 10 kilowatts in 3 seconds, which is the time when taken average for starting the engine. That is the funda he had used. You start the motor, let the engine start. Engine starts, becomes self-sustaining within seconds, and that is the time you declutch the motor. That way you save the motor. Okay, this is exactly like a person walking on the coal. What is the miracle here? He knows his thermal time constant. So before his toe burns, skin of the under skin of his surface of the toe burns. He lifts it, it takes it, goes ahead. That is how he beats the burning coal, because there is again thermal time constant is the root cause. And from that time, the motor, starter motor, was built, incorporated, but mechanical cranking was still kept there for some more years, so that if motor is not there, I can do it manually, like your electric window winders. Earlier window winders were manual, and then it became electrical. So this is a lesson. And before we stop, I will tell you how. See, I knew this history because I deliver lectures. Till that time, I also did not know. But when I came into automotive field, I read all the history. I came to know that this is the thing, and this is also a reason why electric vehicle delivers very huge acceleration torque, very starting torque. Because suppose this is a 40 kilowatt, 30 kilowatt motor. But for acceleration, which lasts only for a few seconds, it acts like a 100 kilowatt motor. And it gives you a pickup of a 100 kilowatt motor. That is which no engine can really do. Engine about 20 HP engine, not even delivering 2 HP during your idle. Okay. And this lesson, how it was useful to me in my own consulting work, somewhere in 2021, 2022. But I am from Pune, so Pune Golf Course, they have electric golf carts. It will be there some other side. Pune Golf Course, it has electric golf cart. And they wanted to convert the electric golf cart into an autonomous vehicle. Why? Not because they cannot afford drivers, because they wanted to generate a glamorous experience to attract the footfall, so that those who are playing golf will also bring their neighbors. There are many other entertainment avenues, food, and this is how the golf course will profit. That was the business thinking behind this kind of engineering assignment. So the company which had taken this contract, they were looking for somebody who will change the architecture from EV to autonomous. And somebody told my name. So I was able to do the paper design within a week. They said, you go this way, I will supervise. You will get an autonomous car vehicle that is good enough in a deserted golf course. That is there. That is not very difficult. Now, if it is autonomous, the steering has to rotate by itself. So they need a steering motor. Again, the mechanical engineering. Mechanical engineers, they have two sides. All motion calculations are done by mechanical engineers. 2 pi nt. So what they did, they imagined that in 1 second, easily 2.5 revolution they can rotate. They tried that. How fast they can rotate. So their N is a kind of 2.5 RPS, revolution per second. They measure torque based on the muscle power, force gauge, 2 pi nt. With 2 pi nt, 10 kilowatt motor was coming. So there was a 10 kilowatt motor. They went to motor manufacturer and got the catalog of dimensions, electrical rating, torque rating. The kind of motor they were getting was so huge. They say if such a huge motor I put in the front front compartment where the person will sit in the front, who will how this can be done. Since I knew catering story, I said, I not just even before catering story, I knew this, the thermal time constant of motor, and 1 kilowatt motor easily deliver 10 kilowatt. This everything I knew anyway, but there's a catering story freshly I remembered. I said I will have the similar solution. I said let us go to the motor vendor, and we should not ask him a 10 kilowatt motor. We should ask him that what is the lowest rated motor which delivers 10 kilowatt in 3 seconds. The answer came 1 kilowatt. So 1 kilowatt motor will come. Now 1 kilowatt motor also, I said I will make it even less, 200 watt. How? I said you are not driving this autonomous vehicle in a traffic. You are only driving it in a golf course which is deserted, and people have come to watch the fun. So who asked you to rotate this steering wheel as if you are parking? When you are parking, we make a very brief, very rapid movements of the steering wheel. Here nothing is required. Actually, you can blink the lamps around. Blink LEDs have a music, and really rotate it very very slow. Let people clap, watch it rotate. So in 2 pi nt, first I attack terminal T torque because transient torque is much high. Then I am attacking N. So you say N by 10. You did 2.5 now. Mine is 0.25 revolution per second. So it became around 200 watt motor with design margin, very slow. But that is how engineering research should go. So let me stop here. You have any questions, you can ask me. The entire PPT is very large, but we have to stop somewhere. You have any question, you ask me, otherwise the session is over. There are 6 people here, 6 other AM. UIT mathematics. You can ask me question. If at all any. Otherwise, my number is there. You can add me. You add me on LinkedIn. Then she knows my contact details. You can ask also questions. My number is here. You can be connecting with me, and you can ask also on WhatsApp. Any question, even your project question, E Baha, M Baha, A Baha. If you are doing it, definitely ask me. Otherwise, it is over. I will stop presenting first. And otherwise, afterwards. Then you can coordinate, or who are mathematical association, you can coordinate. It was a faculty.
Yes, sir, definitely.
Okay then. So let us now call it a day. I am looking forward to meeting you sometime this year.
Yes,
Okay.
sir, we'll definitely have some offline sessions.
Offline
Definitely.
session. This is a very large, very huge PPT.
Yeah.
I was actually called for hydrogen event some 2-3 years ago. We started 8 o'clock in the morning, and we never knew how 8 p.m. happened. That was the kind of engagement. Anyway, thank you very much. Thank you. Okay then. Let us now. Thank you. Thank you. Yes, 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 yes. You call me for mathematical association. See, this Monday I am giving a lecture on engineering mathematics, popular lecture on engineering mathematics to Symbiosis Institute of Technology. And my topic is engineering application of mathematical transforms. Very, very interesting. So you please call me even for your mathematical association. Okay. Okay. Thank you. Thank you very much. Thank you.